So we're taking 5a squared b and we're dividing that term by 5ab. And then we're going to take the second term, negative 15ab cubed, and we're going to divide that by 5ab. Guys, you should be writing this down into your notes. Please, write it into your notes. And then we're going to take our third term, 10a cubed b to the fourth. We're dividing that by 5ab. Can you simplify each of these individual monomials? Yes, we should. We did this a couple of days ago. Let's go ahead and simplify. 5 divided by 5, what's going to happen there? Cancel out, are going to be 1. A squared divided by a is a. And b divided by b, well, they're going to cancel out. Minus, let's keep going, 15 divided by 5. What goes into 15 and 5? 5 goes into both. 5 goes into 5 once, into 15 3 times. We have a divided by a. Well, that's going to cancel out. Then we have b cubed divided by b, which is b squared. Let's keep going. What goes into 10 and 5? 5. 5 goes into 5 once and into 10 twice. So we have 2. We have a cubed divided by a squared, and we have b to the fourth divided by b cubed. Can I combine any of these terms together? No, they're not considered like terms, so this would be your final answer. Now, this next example is still an example of a division problem. It just looks a little bit different, doesn't it? And I would encourage you to rewrite it like we did a second ago. 20c to the fourth d squared f. And 16c d squared. It's all divided by what? 4c d. Could you simplify this polynomial divided by a monomial? Chase, sit up. Could you simplify this? Well, sure we could. Do you need to break it apart into 3 separate monomials? Can we leave it together? You should probably be able to do this without breaking it apart. What goes into 20 and 4? 4 goes into 4 once and into 20 5 times. We have c to the fourth divided by c. C cubed. We have d squared divided by d, and the f's are going to cancel. For the second term, we have negative 16 divided by 4. What goes into negative 16 and 4? 4 goes into 4 once, into 16 4 times. We have negative 4. C's are going to cancel. D's are going to cancel, and we're left with f. Minus 4f plus. What do you notice about the last term and? This is what we call our divisor. What do we know about those? They're the same. So is it going to go away? It's 1. Because isn't 4 divided by 4 1? So we do need to say plus 1. The next example is written different yet, isn't it? Now you'll notice that that last parenthesis is raised to the negative 1 power. If we have something raised to the negative 1 power, what does that mean? Change floors. Now does everything change floors? No. Just that parenthesis, correct? So of course that means 18x squared y plus 27x cubed y squared z, all divided by 3x y. When we change floors at negative 1 exponent becomes a positive. We cross the line, we change the sign. So let's simplify. What goes into 18 and into 3? 3 goes into 3 once, into 18 6 times. We have x squared divided by x. And then the y's will cancel. What goes into 27 and 3? 3 goes into 3 once, into 27 9 times. X cubed divided by x is x squared. Y squared divided by y is, what about z? I don't have anything to divide it by.
Bring it down.
It's just z. Right, that is our last example of taking a polynomial divided by a monomial. We're really just doing what we did a few days ago, aren't we? We're just breaking it down to individual monomials to simplify. Now, these next few examples, we're going to get into some polynomial long division. We're going to go back to about 5th grade here. Back in 5th grade, your teachers gave you this problem and you were just overjoyed, weren't you? You were really excited to do long division. Okay. No calculators allowed on this. Okay. Can you do this using long division? Okay, so let's go back. We need a refresh here. Let's talk about terminology. Anybody know what we call that number right there? Dividend. What'd you say? That's what this one's called, the divisor, though. We're close. That's 7, we call that our divisor. Or divisor. So we're going to take our dividend and we're going to divide it by our divisor. So we want to know how many times does 7 go into 18? Or how many groups of 7 can I make if I have 18 things? If we have 18 pieces of candy, I want to know how many groups of 7 I can make, right? So the process for doing this was we would think in our minds, how many times does 7 go into 18? Or what is 18 divided by 7? How many times does 7 go into 18? 2. Did I agree with 2? 7 times 2 gives me 14. So we're going to write 2 above the last digit that we're using is 18. So then we would multiply, wouldn't we? Guys, I really need you to focus, please. 2 times 7 is 14. Do you remember what we did next? You guys do remember that. Subtract. 18 minus 14 is? 4. Now, probably in 5th grade, your next step is you would say R4, wouldn't you? Not in algebra 2. We can't say R4. It doesn't work that way. It's going to be written as a fraction. Does anybody remember what the fraction is?
You just put a 0
Okay, you're thinking keep going to decimals. I want it as a fraction. Yes, good, Caitlin. 4 over 7. We're going to take our answer, our remainder, and we're going to divide it by our divisor. So we have 2 and 4 sevenths.
Yeah, big on 4.
I think my answer is better.
Okay, so here's what I want you to do. You have a calculator? Yeah. Let's check our answer and make sure we did it right.
It's 2.57.
Alright, so we have 2 and 4 sevenths, right?
Yeah.
That was our answer. So on your calculator, type in 4 divided by 7. It's like 0.5714. Now we have 2 and 4 sevenths, correct? So it would be 2.57. Remember that number? Can you remember that 2.57 in your head?
Yeah.
Now then I want you to type in 18 divided by 7. Is it still going to give us 2.57? It does. So that tells us we did our long division correctly. Let's look at another example. So this time I want to know how many groups of 7 can I make out of 573,457 pieces of candy. Okay, I want to know how many groups of 7 I can make. Well, let's do our long division to figure this out. Does 7 go into 5? Okay, so I want to look at the next digit. So does 7 go into 57? Yes. 57 divided by 7 is what? Or how many times does 7 go into 57? 8. So I'm going to write 8 above my 7, my last digit used. So 8 times 7 is? 8 times 7 is? Write this down. Michael, you write this down? You need it on your note sheet. Then what are we going to do with 56? Right, but you know all this is on your note sheet, right? So 57 minus 56 is 1. What do we do next? Bring down that 3. The 3 just comes down, doesn't it? So we're going to do this process all over again. Does 7 go into 13? How many times? Goes in there once. It can't quite go in there twice, can it? So I'm going to write a 1 above the 3. So 1 times 7 is? Okay, so then what do we do with the 7? We always subtract. 13 minus 7 is? 6. What's next? Bring down the 4. So how many times does 7 go into 64? 9 times. So write 9 above the 4. 9 times 7? 63. Then what are we going to do with 63? Subtract it. 64 minus 63 is 1. What's next? Bring down the 5. So how many times does 7 go into 15? 2 times. So 2 times 7 is 14. Or subtract. 15 minus 14 is 1. Bring down your 7. How many times does 7 go into 17? 2 times. 2 times 7 is 14. Subtract. We're left with 3. So again, we're not going to write R3 for remainder 3. It's going to be what? What's our fraction? 3 sevenths. Just coming back to a little bit on division.
How would you have 3 7s?
Huh?
How would you have 3 7s?
Well, I don't know. But I'll tell you a story. Yesterday, Brady and Bella, they brought home 5 cookies from daycare. And they had to split 5 cookies between 2 people, right? So you can guess what I did. I made it into a math problem. And I asked Brady, she's 4, so you got to come in. She's only 4, she's not in school yet. I said, Brady, how many cookies are each of you going to get? She thought about it. She had all the cookies out, and she gave Bella 2, and she kept 3. I said, well, that's not even. Bella only got 2, and why do you get 3? I said, well, what are you going to do with that last cookie? And you know what she did? She broke it in half. So she was able to recognize that she's going to get 2 1/2 pieces of cookie. Are you not impressed? She knew how to do fractions is what I'm getting at. She could do fractions.
She knew she was wrong.
She knew she was wrong. Trevor brought up my story. He said, how can you have 3 7 pieces of candy? Well, Brady would just break it in half. Let's do one more. Because I want to make sure you guys are really good at this long division before we start doing it with polynomials. Because it's the same thing, just with polynomials. So 11, does 11 go into 1?
No.
Does 11 go into 12?
Yes.
How many times? Once. So 1 times 11 is? 11. Then we'll subtract. 12 minus 11 is 1. What do you do next? Bring down the 8. So 11 goes into 18 how many times? 1 time. 1 times 11 is? Now subtract. 18 minus 11 is? Bring down the 4. So 11 goes into 74 how many times? 6 times. 6 times 11 is? Then subtract. 74 minus 66 is 8. Bring down the 5. How many times does 11 go into 85? 7. 7 times 11 is 77. 85 minus 77 is? 8. Bring down the 7. 7 times. 7 times 11 is? 77. So 87 minus 77 is? 10. What's our remainder? 10 11s. Okay. So you guys should be able to do this easily, right? You got this long division down? You ready for your homework?
Oh, was that a long word?
No. Alright, we need to do some polynomial division.
Long division.
Okay, so you have this example, you have it all written down, follow along with me here. It's the same thing. It is the exact same thing. Good complaint. Okay, so my question is, we're taking x squared plus 6x minus 10, and we want to know how many groups of x plus 2 I can make, right? How many times does x plus 2 go into x squared plus 6x minus 10? So x, how many times does x go into x squared? Or, we can think of it as what is x squared divided by x? X, you agree? I'm thinking x times what is going to give, guys, I need you to stop talking and pay attention. If I take x times x, does that give me x squared? Okay, so I'm going to write x above the term that it's alike. Okay, do this with me on your notes. So now what do we do next? After we wrote our number up there, what did we do? We multiplied, didn't we? Now we're taking x times x plus 2, so we're going to have to distribute. X times x is x squared. Put it below your like term. Distribute. X times 2 is 2x, so put it above your like term, or below your like term. Now, after we multiplied, what did we do? Subtracted. So now we're going to subtract both terms. So I'm going to make them both a negative. Now x squared minus x squared, those are going to cancel out. I have 6x minus 2x, which is 4x. What did we do next? Brought it down. So bring down your minus 10. So how many times does x go into 4x? Or you could divide. You could take 4x divided by x, which is divided by 4. So I'm going to put 4. So now what do we do? We multiply. 4 times x is? 4 times 2 is? After you multiply, what do? Subtract. So we're going to change those signs. So 4x minus 4x is going to cancel. What is negative 10 minus 18? Negative 18. Now, your answer is here and here. But it's not x times 4, is it? It's really x plus 4 because that was a positive 4. So our answer is going to be x plus 4 plus, what was our remainder? Negative 18 divided by, just like we did before, negative 18 divided by x plus 2. Trevor. Where?
How to find out the whole problem.
We're going to do a lot more together.
Okay.
Okay? Stay with me. Guys, when you get to college algebra, you're going to be finding equations for asymptotes. And you know how you're going to do this?
I don't know.
Right here, with long division. Right, you need to know this process. Right now, we're just practicing dividing it. You will utilize this a lot more when you get to college algebra, and Mrs. Freckle doesn't spend a lot of time going back over long division. It was important that you get it now. I want you guys to be successful then. Let's keep going. I'm going to do lots of examples. You have them all written down. I want to rewrite this problem. We're dividing by a binomial, correct? So I can't do the division that we started doing because there's 2 terms here. So I'm dividing by x minus 2. That needs to go on the outside. That's my divisor. My dividend is what I'm dividing. I'm dividing x cubed minus 5x squared plus 4x minus 2. So just like we did on long division. Yes.
You said x minus.
Oh, thank you. I did. I wrote plus instead of minus. I need to go back there. So let's do just like we did on long division when we had numbers. How many times does x go into x cubed? Okay, so we would write it as x. No. Divide. You're dividing. X cubed divided by x is x squared. So it goes in there x squared times. So we're going to write x squared above our like term. Okay? Just like we did before. Trevor?
So wait, like the first number under like the first number of the dividend. Okay, so x cubed u is subtracted by like the x.
I took x cubed divided by x.
Okay, so it would be x squared.
Mm-hmm.
And then you put it over the x.
Put it like that.
Okay. And then
What do we do next?
I don't know.
What would we do if we wrote the number up there with long division? We did what?
Times the
We multiply. So we'll distribute. Check.
Sounds like trying it's still over 5x.
Well, whatever this number is going to go above your like term. Always go above your like. Eventually what you'll get to notice, Chad, is if you're missing a term, we'll get to that. If you're missing a term, it'll just be a reminder to put it in there. So let's multiply x squared times x minus 2. So x squared times x is x cubed. X squared times negative 2? Negative 2x squared. Now, after we multiply, what do? Guys, you should be writing this down. There is no way you can memorize this process. This is new, brand new. You've never done this before. Write it into your notes. After we multiply, what do? Subtract. So really I'm changing my signs. I'm multiplying by negative 1 or subtracting. So x cubed minus x cubed is going to cancel. Negative 5x squared plus 2x squared is negative 3x squared. What did we do next? Think about your long division. What did we do next after we subtracted? Brought down the next term, or the next digit. Now multiply. X times what is going to give me negative 3x squared? Or divide negative 3x squared by x. Negative 3x. So put that above your like term. Negative 3x. Now multiply. Negative 3x times x minus 2. Negative 3x times x. Negative 3x squared. Negative 3x times negative 2. Positive 6x. After we multiply, what do? Subtract or multiply by negatives. The x squares are going to cancel out. 4x minus 6x is negative 2x. What are we going to do next? Bring down the negative 2. So negative 2x divided by x is negative 2. Now multiply. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Now subtract. Change your signs. So negative 2 minus 4 is negative 6. So we write our answer is going to be plus negative 6 divided by what? X minus 2. We may not always have a remainder, but if we do, this is how we're going to write our answer. And we need to look at one where we might have some missing terms. Skip that next one. I'm going to go to this one here. Okay, a couple of things are jumping out at me in this one. Usually what comes first in our divisor? The variable. We need to flip that around, and that's going to be an easy switch, isn't it? We're going to make that a plus 2. You need to keep it in that order. I want your variable to go first. And addition is commutative, so we're good. Is there anything else you notice here in your dividend? We're missing a term. What term are we missing? The square term. You cannot do long division if you're missing a term. We are missing we're missing a squared. So I'm going to add it in. So we have 2a cubed plus 0 a squared. If we add something in, we have to add in 0. We can't add anything else. We're going to add 0 a squared plus a minus 3. Everything else is staying the same. But you have to have every term in the correct order. If it's not, you cannot do long division. You have to add it in.
So you just plus
You can't add a squared because that would change the value.
Minus 0, a squared.
Yes, you can add 0 a squared, just not a squared. So then let's multiply. 2a cubed divided by a is 2a squared, so it's right above our like term, 2a squared. Now multiply. 2a squared times a is 2a cubed. 2a squared times 2. 4a squared. After we multiply, we subtract. The a cubes are going to cancel out. 0a squared minus 4a squared is negative 4a squared. Then we bring down that next term. Now, negative 4a squared divided by a, negative 4a. Negative 4a times a, negative 4a squared. Negative 4a times 2 is negative 8a. What are we going to do next? Subtract, so change your signs. A squares are going to cancel out. A plus 8a is 9a. Bring down your next term. 9a divided by a is 9. So then multiply. 9 times a is 9a. 9 times 2 is, now subtract. Negative 3 minus 18 is a negative 21. So we have 2a squared minus 4a plus 9 plus a negative 21 divided by a plus 2. And this problem is important that we just did, this last one, because you've got to remember to include those missing terms if you have any. How different is the process for dividing polynomials than it is for dividing numbers? Is it very different?
Yes.
No, they're very, very similar. It's the same process, the same steps. We're just using polynomials instead of numbers. I do have some problems for you to try and practice that you guys need to start now. Hang on to this sheet here because we will be doing some more of this.